In this video, we learn how to compute the sample size needed to estimate a proportion to within a specified margin of error. For example, suppose we want to estimate the proportion of likely voters who are planning to vote for a presidential candidate. How large of a sample do we need in order to obtain a 95% confidence interval with a margin of error of no greater than 3%? To do this, we're going to use the formula for the sample size presented in the course notes and in the textbook. In the formula for sample size, n represents the sample size, z sub c is the number of standard deviations needed to achieve a particular level of confidence, and those values are shown in the table to the right. E is the desired margin of error, and p hat is the sample proportion. There's something a little tricky about the sample proportion, since we're going to be doing the sample size calculation before the study, and we don't know the sample proportion until after we complete the study. The way around this is that we need to find an estimate for the sample proportion. We can use a previous study if one is available, and if there are no previous studies available, then we can use a sample proportion value of 0.5. Since this results in the largest possible sample, and it's better to have too much data rather than not enough. So let's proceed and calculate the sample size for these two scenarios. In part A, the sample size is equal to z sub c, which we can read off of the table. In this case, we're doing a 95% confidence interval, so z sub c is 1.95996. We're going to divide this by the desired margin of error, 0.03, which we do need to represent as a decimal. Square it, and then for the value of p hat, we're going to use the results of the previous study, which is that p hat is equal to 0.35. So substituting that in, for p hat, I have 0.35 times 1 minus 0.35. I would need to enter these values into a calculator, and I would obtain a sample size of 972. In part B, we repeat this calculation, but we assume that we don't have any previous polls or information for this candidate. So in that case, we start off the same as before. The sample size n is equal to 1.95996 divided by 0.03 squared. And this time we use a sample proportion of 0.5. So I'm going to enter 0.50 in for p hat, and I will have 0.5 times 1 minus 0.5. Enter this into a calculator, and I come out with a sample size of 1068, where I am rounding up to the next higher integer. So as you can see, if you assume a sample size of 0.5, you end up needing a larger sample, but it's better to have too much data rather than not enough data. So the way to handle these types of problems is if you do have a previous study, you can use the value of the sample proportion from the previous study. If you don't, then you should use a sample proportion value of 0.5.